lines and the triangle sum theorem. Let's start with the warm-up. We're going to classify each angle as acute, right, or obtuse. Now, if you're not sure if it's an acute angle, a right angle, or an obtuse angle, and you're just asked to classify, grab a piece of paper. That corner is a right angle. If you hold it up to the angle and it matches the corner perfect, it's a right angle. If it's larger than the corner of your paper, it's an obtuse angle. And if it's smaller, meaning it's less than 90, it's going to be an acute angle. So number one, if you hold that paper up, you're going to see that it's larger than the corner or larger than 90 degrees. So this is obtuse. And number two, it's smaller than that corner or smaller than 90 degrees. So it's acute. Let's go ahead and solve a couple of equations. Number 3 says that 30 plus 90 plus x equals 180. Well, 30 and 90 gives me 120 plus x equals 180. If I subtract 120 on both sides, x equals 60. Number 4, we've got 55 plus x plus 105 equals 180. 55 and 105 gives me 160. So I have 160 plus x equals 180. If I subtract 160 on both sides, x equals 20. The objectives for this lesson are to classify triangles and find the measures of their angles, and to use exterior angles of triangles. Okay, we can start with an activity. What you need to do is grab a piece of paper and a ruler and a pair of scissors. Draw a triangle. Use the ruler to make those sides nice and straight. And then cut your triangle out. And after you do that, go ahead and label them 1, 2, and 3. Label the angles. Once you have your triangle cut out and the angles labeled, go ahead and rip off those angles. So I've ripped off angle 1, and I'm going to rip off angle 3. Doesn't matter, you can rip off all 3 of them. I'm going to rip off those 2 so that I can hold them up for you. Then take those angles and put them next to each other in any order, just as long as the right side up works better. If they're upside down, it'll still work, you just can't see them as well. If you take those 3 angles and put them together, you should notice that they form a straight line or 180-degree angle. So the measures of those 3 angles in that triangle make 180 degrees. No matter how many times you do this, it should turn out that every triangle, the 3 angles in that triangle, add up to 180. So what it looks like is you've got these 3 angles you put together, and they make that line, which is a 180-degree angle. Our theorem says that the sum of the measures of the angles of a triangle is 180. Any triangle you have, I'm going to label this A, B, and C. Those 3 values, A plus B plus C, equal 180. We can use the angle sum theorem to find missing angle measurements. Here we're asked to find the measure of angle 1. We've got a triangle with one angle of 35 degrees, another angle of 65 degrees, and then our missing angle. We can say that the measure of angle 1 plus 35 plus 65 equals 180. 35 and 65 is 100. So I have the measure of angle 1 plus 100 equals 180. Subtract 100 on both sides. That leaves us with the measure of angle 1 equaling 80 degrees. Okay. We can try it with the more complex problem. Here we have 2 little triangles put together to make one larger triangle. And we're asked to find the values of x, y, and z. I'm going to start with x. I see this triangle here, triangle GJF. One of the angles is 39, another angle is 65, and the third angle is x. So I've got 65 plus 39 plus x equals 180. 65 and 39 gives me 104. So we have 104 plus x equals 180. If we subtract 104 on both sides, x equals 76. So this is 76 degrees. Well, now I see that x and y are side by side making a straight line. So x plus y is 180, or 76 plus y equals 180. Subtracting 76 on both sides, y is 104. To find my last angle, angle Z, you can use the large triangle GFH. Or you can use that little triangle. I'm going to go ahead and use the little triangle, and I see that in triangle GJH, I have a 21-degree angle, a 104-degree angle, and angle Z. So I've got 21 plus 104 plus Z equals 180. Well, 21 and 104 gives me 125. And if we subtract 125 on both sides, Z equals 55. Okay, classifying triangles. We classify them by angles, and we can classify them by sides. Let's start with what happens when we classify them by angles, or what do we call them? Equal angular means that all of the angles are congruent. What it looks like in a picture, you're going to have a triangle, and all three of those angles are the same measure. In fact, if they're all three the same measure, 180 divided by 3 is 60, so all three of those angles are 60 degrees. An acute triangle is a triangle where all three angles are less than 90 degrees. So one example would be that equal angular, because they were all 60, or just any other triangle where they're all less than 90 degrees. A right triangle has one right angle, and you can show that it has a right angle with that right angle mark. An obtuse triangle has one obtuse angle, and so it's going to have one angle that's more than 90. So we could classify triangles by angles. Equal angular has all three congruent angles. Acute has all three angles that are acute. Right has one right angle, and obtuse has one obtuse angle. We can also classify triangles by sides. Equilateral means that all three sides are congruent. Picture of that would have tick marks on all three sides that are the same number of tick marks, meaning that all three sides are the same. Isosceles, an isosceles triangle has at least two sides congruent. So you can have three sides congruent, you just have to have at least two sides congruent, which means an equilateral triangle is a special kind of isosceles. Equilateral, all three. Isosceles, at least two. So an example of an isosceles triangle might be this one here. A scalene triangle, scalene means none of the sides are congruent. So you've got this triangle, and none of the sides are equal. None of those sides are congruent. Classifying triangles by angles, classifying triangles by sides. All right, let's go ahead and classify this triangle by its sides and its angles. Well, I see that these two sides are congruent because they both have one tick mark. And so that means it's an isosceles triangle. And all three of those angles are less than 90 degrees. So it's also an acute triangle. So we have an isosceles acute triangle or an acute isosceles triangle. Okay, exterior angles. If you take, for instance, the triangle, and you extend one side, leaving another side well untouched, we'll just go ahead and do it. I'm going to extend this side. So I've taken and I've just extended this side out. This is an exterior angle. An exterior angle is formed by extending one side out and then looking at the adjacent side. So the adjacent side and the extension form an exterior angle. Now for each exterior angle in a triangle, the two non-adjacent interior angles are remote interior angles. What does that mean? I've drawn an exterior angle. The two that are on the other side of the triangle are the remote interior. So for this example, I just put an X for my remote interior angles. So I don't want the one that's next to the exterior angle. I want the two that are across the triangle from it. Those are called remote interior angles. Okay, we've got a theorem about an exterior angle and the remote interior angles. And what the theorem says is that if you've got a triangle and you look at the exterior angle and the remote interior angles. So I'm going to go ahead and call this exterior angle A, the remote interior B and C. It says that B plus C equals A. All right, let's illustrate that with a drawing or an activity. What I've done is I've taken a triangle and I've labeled the points, or the angles, 1, 2, and 3, and I extended one side out. So I have this exterior angle out here. I then took a piece of paper, placed it over it, traced the triangle, and cut the tracing out, or cut the paper that I used to trace it on. I'd cut that triangle out. Now, this theorem says that these two angles, 1 and 2, are going to be the same as my exterior angle. So I can test that by ripping off angle 2 and angle 1, because those are my remote interior angles, and I can check I numbered them the same. 1 and 2 are remote interior to the exterior that I drew. And now, if I place these on here, they should add up to be the same. So I've got angles 1 and 2, if I can get a hold of them. And if I hold them up here, they should add up to be the same as that exterior angle, and I can see that they do. So the measures of the exterior angle of a triangle equals the sum of the measures of its two remote interior angles. The measures of an exterior angle of a triangle is greater than the measure of either of its remote interior angles. All right, well, let's think about what that one is saying. Take any exterior angle, and I'm going to label it the same as that last picture, A, B, and C. This is saying that A is greater than B, and A is greater than C. Well, if B and C add up to equal A, of course A is going to be bigger than both of those angles. If it's not, then when I take A and B, B and C and add them together, I'm going to have an angle that's much larger than A. So this is just saying that my remote interior angles, they're both smaller than the exterior angle. Okay? Find each missing angle measure. I've got an exterior angle here, angle 1, and I have two remote interior, 40 degrees and 30 degrees. Well, all I need to do is take 40 plus 30, because the exterior angle equals the sum of the remote interior angles. That's 70 degrees. B. I've got the exterior angle, and I only know one of the remote interior. I want to find the other one. I know that 70 plus the measure of angle 2 equals 113. If I subtract 70 on both sides, the measure of angle 2 equals 43. I can check this by double checking my addition or subtraction. 70 plus 43 should be 113. All right, we've got a lounge chair. It has different settings that change the angles formed by its parts. Let's look at what we've got in here. I'm going to go ahead and outline or trace this triangle. Okay, this angle down here is angle 2. My exterior angle, looks like I'm going to extend this out. Exterior angle is angle 1, and angle 3 is my other remote interior. So 2 and 3 are the remote interior angles, and angle 1 is the exterior angle. Angle 2 is 32 degrees. Angle 3 is 81 degrees. Find the measure of angle 1, or the angle formed by the back of the chair and the armrest. Well, let's go ahead and take 32 plus 81, because the remote interior angles, if we add those together, the sum of those equals the exterior angle. So that's 113 degrees. So the measure of angle 1 equals 113.